Hello everybody, good evening, welcome along to Space Dave Live, episode number 12. Hope you're all rugged up nice and warm because the weather is absolutely miserable, but despite that we have had a few people brave the weather to come out and join us here tonight, so thank you so much everyone. It's just not pleasant outside at all and it's just wonderful to have you here tonight. So over in the back there you can see Floyd, who is working on social media, the technical issues and working on the competition for us tonight. So let's get started, shall we? Before we do so, I need to talk just quickly about what happened last week after the show. So this is a bit of a downer to get us started tonight, but just within a few minutes of finishing the show last week, we got hit with an automated copyright claim from the BBC regarding those few shots I showed you from the BBC's own trailer promoting their upcoming series, The Planets. But it was an automated copyright claim, and within a few minutes our entire episode had been blocked, effectively removed from YouTube, which was a real downer. I uploaded the recorded version, but this sort of thing hits us really, really hard, and unfortunately the bad news is that this is just the latest in a string of copyright issues we're having. Now the problem isn't that we are showing anything that we're not supposed to. We actually do have permission to do what we're doing, but the system both on YouTube and Facebook is not clever enough to know the difference. And so the automated copyright claims are happening straight away. I then dispute the claim, and the dispute does come back in our favour, but that process takes weeks. So it's just not working out, unfortunately, and there's lots and lots of repercussions of this, and the whole thing is an absolute disaster. So the long and the short of it is we are going to have to, unfortunately, drastically cut back on some of the content that we are showing, which upsets me no end. But it really includes a lot of the cool videos and images that are coming out. We're just going to have to cut right back, at least for the time being, because honestly we just can't really sustain any more of these copyright hits. So that's the bad news to get us started. So what this means is that we are going to be having to follow just a slightly different format, I think, with the show. But as it happens, we were talking about that last week anyway, and talking about how I'd really like to just have more spontaneous stuff and interaction with you folks at home. So we are going to be doing that. Last week we had the competition where we asked for topics and questions and things to discuss, and we had a long list of really awesome things to talk about. So I've got that list with me. It is on the show notes, which we'll talk about in just a sec. So what we're going to do tonight, actually I'll tell you what, let's just have a quick look at our program, shall we, to see what is in store. So after the introduction in the competition and stuff, we'll go through a few news headlines, but instead of showing you videos and other stuff, we're just going to have a quick look at a few websites, and the links to those will be in the show notes if you want to go and have a look more at them. Yeah, I did put the link in the show notes, I think, didn't I? So in the description, both on YouTube and Facebook, you should see a link to the show notes. Now, while I think about it, last week I had a link to the show notes for the previous episode. I got that completely wrong. So for those of you who are wondering why you couldn't find the links, that's why, because I stuffed it up. So sorry about that. I think we've got it right tonight. Let me know if I haven't. So you should be able to look in the show notes and go and see more about those news headlines if you want to do that. In the night sky tonight, I want to have a talk about Jupiter, because it's a good time to be looking at Jupiter. We'll just quickly mention Matariki perhaps, and then we'll get stuck into some of the questions and discussions. So we've got a list of things from last week that we can talk about, but if you want to ask more stuff, do so in the chat. Speaking of chats, let's just have a look and see what we've got happening in there. Hi Sarah, hi Wendy, Fletcher, is it Calman? I hope I've got that right. Welcome John, SL Ormsby and John again. So hi everyone, thanks for joining. So what I would like to do is tackle some of the questions that you guys asked last week, but it would make sense to tackle some of the ones for the people that are joining us again tonight. So we'll try and do it like that. In the meantime, well, first of all, we need to talk about a competition, don't we? So tonight, this is related to one of the questions we had last week. Here's a question for you. Apart from planet Earth, what is your favourite planet and why? So to enter, you just need to post in the live chat, the comments on Facebook or the live chat on YouTube. And if you can start by writing in comp, and then your answer. Then when we go through all the chat and stuff, we can see which ones are competition entries. So write comp, and then which is your favourite planet and why. And one of the questions, I think it was from you, Fletcher, actually, wasn't it? Have I got that right? Yes, it was from Fletcher. What is my favourite planet? And we will cover that a little bit later on. So there you go, that's the competition. Get stuck into that. let's get our housekeeping stuff out of the way. So, whoops, sorry guys, I didn't mean to cut to you there, but hello again everyone. Okay, so what I meant to do was this. Let's have a quick chat about our housekeeping bits and pieces. So first of all, Patreon, just a reminder to everyone about our Patreon page, links in the show notes. If you want to help support the show, please do that. You can go there and you can join up as a member. And we've had several new members in the last week, so welcome on board to these people. We've got Liza and Sarah Bolton, thank you very much for joining. We've got Dennis Howell and Araha Mahani, and Araha is actually with us in the audience tonight. Let's come back to your camera and say thank you very much for joining us tonight, and we've got Greg Spender. So thank you very much, guys. It's a big morale boost as well as a financial boost. Now, Greg, I didn't quite get your one in time to add you to the countdown video that starts just before the show, but I will definitely do that for next week. So thank you again to all our Patreon supporters. A couple of other quick things that I've got to mention tonight. One of them is Matariki. We talked briefly about that last week. We've got Matariki celebrations coming up. And in our local newspaper this week, there was a thing about the Matariki celebrations, and it looked like this. And that is indeed me in the photo there, along with Margaret Owl, who is the coordinator of Matariki festivals here in the Waikato region. So again, the link is in the show notes if you want to go and see what's happening around Matariki coming up. If you're in the rest of the country, just look up what's going on in your area, because I think you'll find that there's an awful lot of stuff going on. Now, just while I'm talking about Matariki, we do have a display here at the Space Centre about Māori astronomy, including Matariki. Now, that screen that you can see in the middle there, when that's turned on, that is playing a waiata about Matariki and the stars. Unfortunately, the waiata I've got is actually an old version that only includes 7 stars. I'm really looking for a waiata that talks about all 9 stars that we now consider to be part of the Matariki group of stars. So if anyone knows of a waiata and would like to sing it for me, or record it and send it through to us, it can be a video with you doing it, with you performing it, or just audio that we can put some visuals to. I would love to have an updated waiata. So just get in touch with me if you are interested in doing that. That would be very cool. Now, there's one more thing I wanted to talk about to do with the Space Centre here. Look what we've got. This is an Oculus Quest virtual reality headset. Now, we've had VR headsets at the Space Centre here for a few years now, and we have a lot of fun with it. It's one of the most popular things that we have here, but we've been waiting a long time to get a really good quality headset that has proper hand controllers, so you've got virtual hands, but it's not tethered. You don't have to attach it to a computer. This is really awesome. We're having a lot of fun with this. That's the good news. The bad news is there's actually not a lot of space-related content for it yet, and unfortunately that Mission ISS experience that people keep asking for, we've got it on the Oculus Rift, but we can't do it on this yet. But if you're interested in booking a session with our VRs, we've got these and a whole bunch of Oculus Go headsets. So if you're interested in our VRs, give us a call and we can talk about the options that we've got available. But yeah, boy, we're having some fun with that. I love VR. Right, I think that is all housekeeping that we had to talk about. So I think it is time for us to get on and talk about some space news. So as I say, we're just going to go through pretty quickly a bunch of headlines here and a bunch of updates. First of all, a quick update to what we talked about last week extensively, the Starlink mission from SpaceX. So if you recall, SpaceX has sent up 60 satellites, and there's a bit of angst about what was happening with all of them. If you're not sure what's going on, check out last week's show where we talked about it a lot. So just a little update really. They are getting somewhat less visible. There's a lot of concern about how much this is going to be spoiling our night sky. We're still not sure exactly how visible they're going to be in the long run, but they are becoming less visible. Apparently all 60 satellites have deployed correctly. They've all deployed their solar panels. They're all working. So the argument is still going on about how much this is going to affect astronomy. I maintain that it is still going to affect astronomy. So I know a lot of people are saying, look, you'll hardly be able to see them, you don't need to worry about it. I say that's good, but it still affects astronomy. Even if they're not visible, as I talked about last week, they still are going to be destroying data. So I'm still worried about it. But anyway, I guess the good side of it is that the satellites are working. Now the plan is to launch thousands of them, of course. But the system will become operational apparently after about 800 of those satellites have been launched. So this is all for faster, better internet access, and that's going to take about 12 more launches. So that's kind of all on track. So still with SpaceX, let's talk about a couple of other quick things. Now, you remember the anomaly with the SpaceX Crew Dragon that happened a little while ago. Not really much of an update, unfortunately. We still don't know what caused the anomaly and what was going on. But interestingly, NASA has come out and said that SpaceX is readying the Crew Dragon for a possible piloted test flight by the end of the year. So this is obviously not confirmed, but the fact that they are hinting at that and talking about it, yeah, I think we'll take that as some good news, that maybe it's not as bad as it could have been. But honestly, we still don't actually have any real update on that. Now, that was from spaceflightnow.com, link in the show notes if you want to go and see more about that one. Still, again, with SpaceX, one more thing, we have been keeping an eye on the Starhopper mission. So this is a SpaceX's next generation, really, really big rocket that's supposed to end up looking something like this, but the version that they're testing at the moment is the Starhopper. Now, we've been talking about this for quite a few weeks. We had the a tethered test a while ago where it just sort of rose a matter of a few centimeters off the ground and it was held down, and we're sort of waiting for the next test to go higher and higher, and it just keeps getting put off week after week. But we're not concerned about that. It's very early days for this vehicle, so you know, it's okay. But the latest is that apparently they are trying again this week, and there could be some tests later this week. So the next test, they are hoping to get up to maybe about 20 meters, and they are starting to talk of plans to have untethered tests, anything from 500 meters up to 5 kilometers, which I guess is a bit further down the track. But SpaceX is pretty bullish about what's going on here. They're pretty confident. So hopefully we will have something more to report in a week or two, other than just it's been put off again and again. So that's SpaceX. Here's another quick news headline. This one is a little bit more depressing. Do you remember this one? We talked about this a few weeks back. I can't remember exactly when. So this is the Stratolaunch aircraft. It's a huge aircraft. I think it's the widest wingspan in the world and possibly the biggest airplane. But we watched its maiden flight. So this was the thing started by Paul Allen, who was the co-founder of Microsoft. And it was all looking very promising. Maiden flight went really well. But apparently, let's see, I've got a story over here about it. This is a story from Reuters, have I got that right? Yes. According to some sources, so definitely unconfirmed, it could be game over. It looks like they're pulling the pin on the whole thing, which is just unbelievable, really, after it finally got its maiden flight going. So we don't know. No one's really saying anything much, but yeah, it could be bad news for those guys. Anyway, link in the show notes if you want to see more about that. But honestly, all it really is saying there is that there are unconfirmed reports from several sources, I think 4 or 5 different sources, but it is unconfirmed. But yeah, we'll see what happens there in the weeks and months to come. Right, I've just got a quick note here. Let's just have a quick look at this. Thank you. So Wendy has just said that apparently you can do something with Apollo 11 mission on Quest. You are absolutely right, Wendy, and we actually do have that. That is one of our options. It's a pretty cool thing. It basically goes through the whole Apollo 11 mission from being on the ground, and you get to just be part of the whole thing. If you're a real spaceflight nerd and you're really into the Apollo missions, it is stunning. It's absolutely awesome. Otherwise, it's quite long and you don't really do much. It's quite passive. But yeah, if you're really keen on the Apollo missions, you will want to do this one because you actually get to feel like you're inside the capsule. You go there and you get the feel for how cramped it was in the Apollo missions. You get to look all around you and stand up. Yeah, it's great. It's a really cool thing to do if you're into that. So thanks for that, Wendy. I'm glad you pointed that out. Where were we up to? Our news headlines. What else have we got here? So NASA, should we talk about this one? NASA has selected some commercial companies to help kickstart the Artemis program, which is the mission back to the moon. Now, these are not missions to send people back to the moon. What they've done is they've allocated some funding, sort of between about $70 and $90 million per company for some missions. You can see some concept drawings here to sort of get the ball rolling, to get people or to get companies taking stuff to the moon and landing some science missions and that sort of thing. So you can see the selected companies are just down here. Now, I mean, this is good news. It's these guys will certainly be happy about it. It's not a big step towards getting back to the moon, but I think it's a positive step. I think what's happening here is that NASA is really helping to kickstart that whole ecosystem of getting companies sort of on the way back to the moon and sort of laying the groundwork for being able to get lots of stuff to the moon that we're going to need once we start sending people there, if indeed that does end up happening. So that's what's happening with NASA. Well, another thing with NASA actually, the James Webb Telescope. So this is the telescope that is kind of in a way the replacement for the Hubble Space Telescope. It's a little bit of a different telescope, but it's been put off forever and it's way over budget. But it is finally starting to get where it needs to be, and it has just recently passed one of its big tests, in that the space station, the spacecraft element of it, the part that carries it into space and where it needs to be, has passed its final testing. So if you're interested in the latest there, go and read the whole story there. So we're getting near the end of testing for the telescope now. I believe the actual telescope part has already finished its vacuum testing. This part's finished its part now. The next part will be to make them together and do a bunch of final testing before eventually they actually finally get to launch. So this is a big deal. This is one of the biggest things in astronomy coming up. So there's a lot riding on this mission. So we're certainly going to be following that with a lot of interest. Still with NASA, but on Mars, Mars Curiosity, the awesome rover. There's a cool selfie from Curiosity rover. Has just found a cache of clay on Mars. So if you're a geologist, that will be of interest to you. If not, I think it's still quite interesting. It sort of indicates water and helps us to learn a lot about the history of what's happened on Mars there. So, yep, there's a story about that. And if we just scroll down, I think there's a few quite nice little moving images here of some of the clouds on Mars. I'm always fascinated to see these sort of things. Because, of course, on Mars, the images we normally get are just still images of things. And it's quite neat to actually see some of the weather and stuff going on Mars. So there you go. That's that one. What else have we got? Here's a story from universetoday.com, great website. Apparently they have recently found and restored some film of the first ever recorded film of a total solar eclipse from over 100 years ago in 1900. The video is down here if you want to go there and watch the video. I'm not going to play it because I'm so scared of the copyright thing now, but there it is. It's right there. To be honest, there's not a lot to it really. It's just you can kind of see what you're looking at there, but it's pretty neat to think that someone was able to record this back in 1900, and there's quite an interesting story about the guy who did that. So link in the show notes, go and check that one out. And if you ever do get a chance to go and see a total solar eclipse in real life, you must do it. It's well worth going out of your way for. You do have to go to just the right place on Earth. It's not like a lunar eclipse when you can see it from pretty much the whole night side of the planet. You actually do have to travel, but if you do, you will not forget it. It's just the most spectacular thing you will ever see. So let's have a look in the chat, because we've got a whole lot of stuff going on here. So okay, Michael, apparently some of the Starlink satellites are misbehaving, are they? That's no good. Okay, I had heard that, but the report I saw today seemed to indicate that they were all going. But thank you for that. Dominic, you came to the Space Centre with your class. I hope you enjoyed your trip there. Cool, thank you for that. Okay, right, okay, so we've got a few things down here. I'm just quickly trying to whiz through them all. Oh, you did the VR. I hope you enjoyed the VR. So you saw the Oculus Go here. We haven't actually started the Oculus Quest with the public yet, but we're going to do that very soon. Okay, so with Pirongia School, yeah, we had Pirongia School here. It was today, wasn't it? I had you guys. Honestly, it's so busy here at the moment, I forget what's going on. Righto, so, okay, I can't quite get through all of them. Am I the only person on this chat that's helping NASA with Bennu? Good point, John. Did anyone else get on board and help NASA find a landing spot for their spacecraft on asteroid Bennu? Tell us if you did do that, because that's good stuff. Good on you, John, for giving that one a go. Righto, so Liz, you like Neptune and you like Uranus, because it is pronounced Uranus, isn't it? We all know that. Right, so what else we've got over here? I hate that planet, to be honest. It's the bane of my life, that planet. Anyway, Tristan, you got your prize, awesome. Okay. Wendy, you saw it in the newspaper. Awesome. Okay. Thank you very much for all that stuff, everyone. I'm trying my best to keep up with the chat. Let's see, what else have we got here? I'm just going to show you a quick video here before we move on. Let me just bear with me while I bring this up. I've actually been hanging on to this for a couple of weeks. This was a video of a launch of the Soyuz in Russia, but just see what happens up about here somewhere. Whoosh! You see that? Ouch! Whoosh! Yeah, it did survive. So apparently it just brushed it off like it ain't no thing. That's the Russians for you. But quite amazing, isn't it? Yeah, just straight through it. Yep, just like that. Good old Russians, didn't bother them at all, just carried on, no worries. But I thought that was a pretty cool video. That's all I've got for that one, so I just thought I would show you that one just quickly. I think that is just about all the news. So, let's leave it at that, because what we need to do next is I want to talk a little bit about what's happening in the night sky. So what we might do is let's head over to Stellarium. So that is our planetarium software. Stellarium, if you're not familiar with it, you can download it. It's free, open source, not open source, but it is free software, and it shows you what is happening in the night sky. So this is what's happening in the night sky right now, but in fact, just bear with me, I'll bring up our date and time window, and we'll just actually go back a little bit to when the sun was setting. Whoops, I'm going the wrong way. Let's just come around here so to where you can see the sun is setting. Now you will actually notice over there, if we just zoom in a little bit, in the evening we've actually got Mercury, the new moon there, and Mars just up here. Very difficult to see. That's not really what we're here to talk about tonight. If we just sort of go forward a little bit, you can kind of see it a little bit better. So they're quite neat over there in the west. But what I really wanted to point out was that as the sun is setting over there, so the sun's just set below the horizon. Now if we go right around to the east, you will see Jupiter rising in the east. What's happening is that Jupiter is currently at what we call opposition. So you can see it here. In fact, if we kind of zoom out much further, you can sort of see those are in opposite parts of the sky. So the sun going down there and Jupiter over there. So this is a really good time to be looking at Jupiter. It's very bright, you really can't miss it over there in the sky, but I'm hoping that this will work, so bear with me. What we're looking at now, this is Celestia. I've just swapped over to a different program, so we were looking at a planetarium program that shows you the sky from the Earth. What we're looking at now is we are now out in space, so this is a simulator out in space, so we can see where everything is. What you're looking at there is the sun. That is our sun if we get up close to it, but we need to zoom out a little bit and hopefully show you the orbits of the planets. So those blue lines are the orbits of the planets. You've got Mercury, Venus, Earth and Mars there. And then you'll notice that there's a big jump out from Mars to the orbit of Jupiter and the other gas giant planets out there. And what I would like to do, so this is the first time I've actually tried doing this on this show, so hopefully this works. If we select the orbit of Earth, so you can see Earth there, and if I actually let's see, so we'll just put a mark on Earth there. So now you can kind of see that green, you see the little green diamond there. So that's where Earth is right now. Then if we come out and we will select Jupiter. So that is the orbit of Jupiter. So you can see Jupiter, where are we? Over there. So hopefully you can see, if we just zoom in perhaps a little bit and go up there, you can see that you've got the Sun, Earth and Jupiter. So does that make sense? Jupiter is in the opposite direction from the sun. That's what opposition means. So we're there on Earth. If you're looking towards the sun in that direction, that's what we saw before on Stellarium. You can see the sun setting. If you look in the other direction, in the opposite direction, that's where Jupiter is out there right now. Am I making sense so far to everyone? Okay, what I'm going to do now is I'm going to speed up time, and let's go for about 1 month per second. So this is speeding up time, so it's going to take Earth about 12 seconds to complete one orbit once, and the planets closer to the sun go faster. Planets further out go slower. So every now and again, like just then, the Earth kind of catches up. It goes ahead of Jupiter, so about now it's on the other side. You can't really see Jupiter there because the sun's in the way. Then we come back around again and there'll be another opposition about there. You see, so every time we sort of come around and we get between the Sun and Jupiter, that is called opposition. So that's where we are at the moment. We are at opposition with Jupiter, so it's right there in the night sky, easily visible. So I hope that made some sense. Pardon? If it wasn't raining, you're not going to see much tonight, are you? I'm afraid. Hang on, let me just go back to the current time. So that is where we are now. So yes, indeed, if it was nice weather outside, you would be able to go outside. Where are we? So again, whoops, that's not what I wanted to do. If you go around to the west, in fact, well, it's a little bit later than that now, of course, but yeah, you see the sun setting over there, and on the opposite side, there is Jupiter. So I hope that kind of makes some sort of sense. That shows that where we are in space compared to each other. So get out there and have a look at Jupiter. Now, we did want to quickly mention Matariki again. Now, we have been talking about that, and we've mentioned that it's not really time to go and see it just yet, but we are getting there. So if we go through to the morning, let's go through to about 6 o'clock. So you can see over there in the east, the sun's coming up. You can see Venus there. Venus is a morning object at the moment, and below Venus there somewhere is Matariki, but you can't see it because it's just too bright. It's too close to the sun. What I'll do is I'll take away the atmosphere. So this button down the bottom here, that takes away the atmosphere, so you could see if you weren't getting all that refraction and reflection from the sun, you can actually see Matariki there just below Venus. So technically it is rising before the sun at the moment, but of course you put the atmosphere back there and you can't actually see it. So what we'll do is we'll just go forward a day at a time. Actually, we probably want to come back a little bit earlier in time, and you can sort of start seeing it there. So about halfway through the month here, and towards the end of June, you can start seeing it a lot more clearly there. So we'll be keeping an eye on that in the weeks to come. So there you go, that is what's happening in the night sky right now. So it's coming up to 7:30, and hopefully we're timing this all right, because we really want to get stuck into talking about some of the questions and things that have been proposed. So before we do that, let's just see if there's anything else much happening on the chat. Caitlin, you have joined us tonight because I'm glad about that, because I want to talk about one of your questions. Oh, okay then. So you're at the college opening. Okay, so does that mean you're watching the show, Caitlin? Let me know, because I've got an answer to your question. Okay, so actually, I'll tell you what, we'll do it anyway. First of all, Fletcher, you had a question last week. What's my favourite planet? My favourite planet, apart from Earth, I think is Mars. It is a little bit of a toss-up, but why don't we go back to Celestia, actually. Let's just go back over here. We'll get rid of all the markers and orbits and everything, and we will try and find Mars, and we'll go and have a quick nosy at it. I thought I got rid of those markers. Go away. So Mars, let's go and have a quick look at Mars. Mars is a beautiful planet. I think it's really awesome. I just can't understand people who look at Mars and think it looks like a boring planet. I think those people are boring. Mars is an awesome planet. It's beautiful. Just look at it. It's got so much cool stuff on it. It's got those big volcanoes. Of course, it's got the biggest volcano in the solar system. It's kind of upside down at the moment, isn't it? I shouldn't say that about planets, because there is no up or down in space, but you do tend to think of it like that. But if we come around here, I'm going to cheat a little bit here. I'm going to lighten the dark side of the planet so we can see a few things there. It's got the tallest volcano in the whole solar system, which is right there. It's about 3 times as high as Mount Everest. Those other volcanoes there. It's got Valles Marineris, that enormous canyon system there that's bigger than New Zealand, basically. I think it's just such a fascinating planet. In fact, I can't help myself. Bear with me. I'm going to show you another couple of quick photos. I just need to pull them up here. Where are we? Mars. Let's have a look. Yeah, let's have a look at some of these photos. That'll do. These are just a few quick photos that have been taken by some of the rovers over the years on Mars. I think it's just spectacular. There's so much cool stuff to look at. You can see some of the sediment layers here that help us learn about its water history and its past. This is from one of the rovers. You can see its tracks along there. Here's a look at the sky. I think I used this one to show you that the sky on Mars is red during the day and blue when it's a sunset. That's pretty neat. And here's just a couple of pictures from space. What was that? It's an avalanche. There's a dust devil there from space. Here's some things that I have no idea what they are. Perhaps some geologist could tell me. Honestly, I've got no idea what we're looking at there. I just thought they looked cool. But no, anyway, so... They do look like drill sites, don't they? Oh God, that'll get the conspiracy theorists going, won't it? Anyway, so yeah, I think Mars is just a spectacular planet. I really love it, and I think that apart from Earth is probably my favourite, maybe Saturn as well. Anyway, so Fletcher, that answers that question. Caitlin, I quickly wanted to answer your question as well, because your question was, what does it take to become an astronaut? Now, I just want to show you a quick thing on the NASA website here. Now, I've got the link in the show notes, so go and check that out. Basically, this page just talks about what you need to be an astronaut. So have a look down here. What it does is it does tell you the qualifications that you need. So you need a university degree, you need at least 3 years of work after you've done your degree, and you need to do some pass some physical tests and that sort of thing. So in a nutshell, that's kind of what you need to be an astronaut, but there is a lot more to it than that. So I've been lucky enough to meet a few astronauts over the years, and some of the tips that they've given me is one of the most important things about being an astronaut is that you have to be able to follow instructions and learn how to do things quickly. So you need to practice that. And a big part of that is because when you're up on the space station, we've talked about this recently actually, you'll get science experiments sent up there, and you need to learn how to do a whole lot of stuff very quickly and very accurately. You need to be able to read instructions properly. We're big on that at the Space Centre here. When you do some of the activities here, part of the process is how well you follow instructions. And I emphasise it even with our competition on the show, how well you follow instructions. It's a big part of it. The other thing is you've got to be social. You've got to be able to get on with other people. You've got to be able to live in close quarters with people for a long time, and that can be quite challenging. People get sick of each other when they're stuck so close to each other for a long time. And there's quite a lot of funny little things that can be a showstopper for you. For example, I'm not going to make a good astronaut because I'm a jiggler. When I sit down, my leg bounces up and down. I'm one of those people that does that really annoying thing. And apparently, that's one of the things that can get you ruled out as being an astronaut. So any annoying little habits that you have like that can get in the way of you becoming an astronaut. So you really got to pay a lot of attention. So there you go, that's just a few things, but go and read the website. There's some really neat stuff there about everything that you need to do to become an astronaut. Now that was a couple of easy questions. What we're going to do tonight is we're going to take on a couple of difficult questions as well as some other easy ones as well. So I think it's time that we take on one of the difficult questions. This is a question that has come from Mike from Cambridge, who asked me some questions about the Coriolis effect. Now, let me just grab a prop. Now the Coriolis effect, you may have heard of this. This is the effect that makes things swirl around in different directions in the northern hemisphere and the southern hemisphere, and you most often associate it with hurricanes and things like that. So to be honest, I'm not a meteorologist, and I'm not really that keen on trying to explain and discuss this, but I'm going to give it my best shot. So we've got the Earth here. Let's see, the Earth is rotating around and around like this. Okay, so as it spins around, if you can imagine, the part around the equator needs to be going a lot faster than the parts up here to get around at the same time, of course. It's a solid planet, so it's all got to move at the same rate. So if you can imagine, you're spinning around quite fast at the equator, but you're hardly moving at all when you're up near either of the poles. So this part of the Earth is moving much more slowly than this part down here. Now, what the Coriolis effect is about is that if you've got something, let's say for example at the equator, and it goes up into the air and goes north, what's going to happen to it? Because, well, let's say you're around here somewhere. Actually, we should go around to the States where they have lots of hurricanes, shouldn't we? Let's say you're down here somewhere. Now, actually, I should point out that hurricanes don't really form around the equator. I should just point that out. But let's just say that you've got something at the equator. Let's say you've got a cannon and you're shooting a cannonball up towards the north. Now, the ground here is moving at a certain speed, but it's moving faster than the ground is up here. Now, when you go up into the air and head north, you've still got that east-facing velocity. You are going at a certain speed, heading in the east direction. You've still got that speed when you start going north. You don't just lose that velocity. So if you start heading north here, you're going to end up going faster relative to the ground than up here. I don't know if this is making any sense at all. I hope it is. But if you head north from here, you're actually going to end up going out in this direction because you've still got that speed, that fast speed going east. It's faster than you would have been up here. What that means is that if you head north from the equator, you're actually going to be deflected off to the side. If you're up north and you're heading south, it's kind of the opposite because the ground below you is going to be faster than it was when you were up here. Which I should be holding this up a bit, shouldn't I? Sorry about that. So you're going to end up getting deflected out that way. So things going this way are going to get deflected that way. These things are going to get deflected that way. And you end up with this anti-clockwise motion up there. And that's why in the northern hemisphere, hurricanes rotate anti-clockwise. In the southern hemisphere, it's the other way, and hurricanes and weather patterns down here will rotate in the opposite direction. So I'm hoping this is making some sense. Tell me, guys, is it making any sense at all? Okay, because as I say, I'm pretty nervous about trying to explain this one. So that was the easy part. Is there anything, actually, I should also point out that it's a myth that the Coriolis effect affects things like the toilet water. You often hear this, that if you go down to the southern hemisphere or the northern hemisphere, the water in the toilet or in a basin or anything goes down in the opposite direction. Now, technically speaking, if you really want to be pedantic, yes, there is a Coriolis effect, but it really only affects things on a much larger scale. There's no way it's going to affect the water in your bath. So that's not actually true, that it goes in a different direction in different hemispheres. Sorry, what was that, Carsten?
It's just random.
It's just random. That's exactly right. It's random. So, and in fact, I know there's a scam, isn't there? Around the equator, there is these tourist operators that do a scam there in which they try and demonstrate this effect, and they've got little tricks, but it's not real. If you ever see videos of them doing that, it's actually not real. Now, as I said, I've got to be careful about our time here. We're going to run out of time. Look, actually, I'm sorry, Mike, we might have to put the other part of it off, but I just want to quickly mention it. Mike asked the question, does the Coriolis effect affect things that are going directly east or west? Because we talked about if something's heading north or south. Now, to be honest, I'd never thought about this until Mike asked me about it, and my initial thought was, probably not. I don't really know. I guess not really, but I bet it's more complicated than that. And sure enough, it turns out to be more complicated than that. And the main thing that I found is that there are other forces involved here as well. It's not just what we were talking about here. In particular, the centrifugal or centrifugal force, or if you want to call it centripetal acceleration. We're not going to argue about that tonight, but let's just call it centrifugal force. So when something is spinning around, you've got what we can call a centrifugal force sort of pushing it out. So imagine that I've got a piece of elastic with a ball on the end of it and I'm swinging it around. The centrifugal force is what pushes it out effectively. Don't be picky with me about this one. Now, you know what I'm talking about, eh? I'm not going to argue about centrifugal versus centripetal and everything. We're just going to call it centrifugal force. So anyway, if I'm spinning it around, if I spin it faster so that it's accelerating more, it will want to go further out. If I slow down the speed, it's going to sort of fall in towards the middle. Now, if you're spinning around here, and you just, let's imagine that you are going around in this direction, so you've got this east heading velocity, and you head east, you are accelerating in that direction. You're increasing your velocity in the eastward direction, so that means you are increasing your centripetal acceleration, and you're going to want to move further away from the axis of rotation. Now that actually, if you look really closely, is effectively going to take you very slightly south. And apparently it gets more complicated because you've got the different layers of the atmosphere, the different air pressures and whatnot, and in fact it ends up deflecting you even further south. This is as I understand it. Now, any meteorologists out there or people who want to contribute to this, please feel free, in fact that's part of the point of this, to come up with a better explanation than what I'm trying to give here. But essentially, I can see this argument that there would be a much smaller force that is related to the centripetal acceleration that is trying to get you closer or further away from the axis of rotation, which is obviously the equator, or further out this way, whereas if you're falling back in, if you're slowing down, if you're going back eastwards, you're going to want to fall back bit closer to the axis, which is sort of going more towards the poles. So I knew that was going to be a difficult one there. I'm going to leave it there, and I'm going to ask anyone that understands this better than I do and has had more experience at this to see if you can, is what I'm saying making sense to you? Can you give me a better explanation? And we'll just see what comes out of that. So thanks for your question, Mike. It's a really good question, and I haven't forgotten about your other ones either, and hopefully we will follow that up a little bit more. Now, we need to keep moving on. There's another difficult one that we need to cover, but let's not do it just yet. We've got Carsten waiting in the wings over here that wants to talk about this other issue. He's going to help talk about that. But let's just do another couple of quick things first. So now, did I get this one ready? I don't think I've got this ready. Just give me a quick sec. This one is actually for Harry. Are you out there, Harry? You might not be out there tonight. Harry Fraser, are you in the comments there? I'm not seeing you, so actually I'll tell you what, I will give that one a miss for now, and we'll get back to that another time when Harry has joined us. Now, Janet, you had a question last week. You asked, do we see more stars here in New Zealand than they do in other places in the world? And we talked about that, but there was one thing that I forgot to mention that I really should have done. I was just talking sort of more geographically and cosmologically, I suppose, about whether we see more stars there in the sky, but I didn't really think to talk about the light pollution and how much that affects it. So I quickly want to mention that here in New Zealand, we have relatively good skies. We're relatively clear of light pollution compared to a lot of places in the world. And this is an interesting thing. When I first started running evening sessions doing stargazing and stuff, I was staggered to find out that people around the world just don't see stars like we do. People in Europe and Asia, Japan especially, that live in cities go through just about their whole lives without ever really seeing stars. Often they will see just a few of the brightest stars or planets, but just don't see any at all. I've actually had many occasions, especially at the observatory in Hamilton, where people are really seeing the night sky for the first time. And I will never forget a lady who came to the observatory in Hamilton. She was a middle-aged Asian lady, and she had spent her whole life thinking that stars were fictional. She thought that they were just a thing that you had in movies. She thought they were like unicorns or magic or things like that that would just appear in movies. She had no idea that you could actually look up into the sky and see stars. Just unbelievable, eh? So anyway, yes, we do see more stars here in New Zealand than... Yeah. Okay, so now, and just to quickly answer your other question, you also asked, why do stars twinkle different colours? Now, that's an interesting one. You may have noticed this. If you spend long enough looking at stars, you'll notice that they twinkle, of course, but some of them actually change colour when they're twinkling. You'll notice that it happens more often with stars that are closer to the horizon. It's actually not the stars themselves, it's the atmosphere. What's happening is the light from that star coming through the atmosphere is being sort of distorted and refracted as it comes through the air. So if you can imagine a beam of light going through a prism, and it splits up the light into all its different colours. You can kind of imagine that that's happening as it goes through the atmosphere with moisture and other particles in the atmosphere. And as the light goes through the atmosphere, it's hitting different pockets of air, some less dense than others, and it's actually refracting in different ways which affect the colour that you end up seeing. The reason that it happens more close to the horizon than straight above you, if you can imagine, let's say we're here in New Zealand, so it doesn't matter where you are, but if you are looking straight up, you're not looking through much atmosphere. The atmosphere is only a thin layer around the Earth, so you're not looking through much atmosphere when you look straight up in the sky. When you're looking towards the horizon, you're looking through a lot more atmosphere there. So those effects are a lot more when you're looking more towards the horizon, and that's why things closer to the horizon tend to twinkle a lot more. Okay, I think we need to get on to talking about the other question that we had. Now, let's... now, Carsten is going to help me out with this one, but just while he gets ready, I'm going to... you're always ready. Good on you, Carsten. Now, the question was, let's just go over the question first. Now, this was from YouTuber 36012. I'm not sure exactly how you pronounce that. Apologies. But the first question was, can you please explain to me how does a pressurized Earth coexist with the vacuum of space. So let's just quickly cover that one. So I kind of get what you're saying there, and I have heard this argument quite a lot. So if you've got the atmosphere around the Earth and a vacuum out here, how do those two work together? So if we had a chamber or something here on Earth, and you had part of it as a vacuum and part of it as a gas, like our atmosphere, obviously the gas would want to go into the vacuum part and they would just mix. But on this scale, and it's important to remember, a lot of these things work very differently on big scales. What you've got is you've got gravity. That's what's holding the atmosphere against the Earth. It's simply gravity, and there's really not much more to it than that. So you've got a layer of atmosphere around here, and it is being held down by gravity. And there's basically just a balance. So indeed, you do have the pressure from the atmosphere. It does kind of exert an outwards pressure, but there comes a point away from the Earth where that outwards pressure is counterbalanced by the gravity pulling it back in, and you do have a bit of a gradient there, but that's what holds the gravity in place. So I answered that. I basically answered his comment in the YouTube thread and said it was gravity. So he said, "Can you please explain gravity to me?" And I said, I'll give it a shot. And then I've just basically thrown it over to Karsten to talk about as well. So look, Karsten, if you just want to come up and grab the microphone there. So we've actually got, just bear with me a sec, Karsten, I've got your graphics over here, so let's just have a quick look at that. So Karsten has actually put together a few images here that we can talk about as well, so I'm just going to let him talk for a little bit, and I'll just bring up these graphics as we need to. So over to you, Karsten.
Yeah, so thank you for that. Just following up on the air pressure. So if you're on a mountain with 3,000 meters height, you only have approximately 2/3 of the pressure that you have on sea level. So there's really a strong gradient the higher you get. And this is all explained by gravity. So explain gravity. Gravity has been a concept that is relatively new. It just popped up probably 400 years ago, mainly by Sir Isaac Newton. Before that, gravity was kind of the notion that it was a godly defined motion, and no one had really got a really firm grip of that. So Galileo was the first one who experimented with that, and he threw different objects from the Leaning Tower of Pisa, and turned out that they all fall approximately in the same speed, unless you, of course, have a very light object, like in the picture beside, with some feathers and a bowling ball. And at that time, he couldn't really prove that. So there's a nice video done by the BBC, which we can't show. And they use a huge vacuum chamber. And they have this experiment, and they let both objects drop at the same time with pressure, so with standard air pressure, and you see the feathers tumbling down, the bowling ball making a straight drop, and then they evacuate this entire chamber, and it's huge, used for space testing space equipment in vacuum. And then they did the same thing, and the feathers just dropped in the same speed as the bowling ball. So Isaac Newton, can you get back to that page? He came up in 1686 with his universal law of gravitation, and he found out that two bodies with mass just attract each other, and it's the same force between both of them. And he came up with this neat little formula where you multiply both masses and divide it by the square of the distance between those two, and then you have to add a magical factor g, and then you get the force, indicating which force they attract each other. I'm not sure at the moment how he proved that this was true, but 100 years later, Henry Cavendish came up with an experiment. So he built a huge box, which is approximately 2.50 meters wide and probably the same height. And what you can see there is these two balls, which are lead balls, 158 kg each, and they are suspended. And then there's a couple of smaller spheres, and they are very small. You see them just beside on the outside of this apparatus. And they are on a so-called torsion balance. So they are hanging on a little stick and can rotate freely. So the purpose of this experiment was to figure out how the big balls attract the small balls. So he put this all in the box so that there's no air, no wind disturbing this balance. And what this does is, so it's totally independent from Earth gravity because that's all perpendicular. It doesn't have effect on the attraction of these objects. And if you can go to the next slide, please. So this is a kind of more cleaned up version of this. You see these two red balls, so they are turning freely and they fall against the bigger grayish ones. And this is the experiment. So it's set up, this little pendulum is put in a certain position, and then it's just observed how quickly they fall against the bigger masses. And by just recording the time and the speed, how fast this works, you can finally figure out this magical G factor that Newton put in his formula. Does it make sense in a way?
Yeah.
Yeah. So, unfortunately, Cavendish wasn't able to do that by himself. That was a couple of years later, a fellow scientist actually did the math around this, and he calculated G with some very small number, 6.74 times 10 to the power of minus 11, so that's rather small. So that means if you have two objects of 1 kilo, you can barely measure the force, unless you have a really sensitive apparatus. But if you put in, can you go back to the Newton formula, please? So if you can imagine, you put M1 is, you put in Earth mass there, and you put in M2 just a kilogram, and put G put in G as the value that is found for this Cavendish experiment, and your distance, let's say 10 centimeters. Oh, sorry, Earth mass 1 kilo, and put the radius as the Earth radius, you get approximately the weight of this 1 kilogram. So this is proving that this formula is actually working. So you can also use one mass as the Earth mass and one as the Sun mass. Then you can calculate how much the attraction between the Earth and the Sun is. But unfortunately, you can't measure that really. At least not directly. So you can do a bit further math and use Kepler's calculations and rules. How are they called in English? Kepler's laws of orbital.
Laws of planetary motion?
Yeah, exactly that.
Yeah.
And then you can start calculating the Earth orbit and find out, oh yeah, it ends up with 365 days approximately when you put in these masses.
Right.
So I've done that in school actually. We also had a nice experiment from the Cavendish experiment, not 2.50 m, but in desktop size. And the big masses were probably just a kilogram lead ball, small ones. And that was part of our physics education to do this experiment. Okay, yeah, I think I just want to iterate. So sometimes flat earthers claim that gravity doesn't exist, that we're living on a surface that is constantly accelerated. So that we experience this force that we feel when we fall down or throw objects off the table. And actually that is correct, because if you were sitting in a box, you couldn't tell the difference whether you're actually attracted by a massive object or if you're moving up. So if you're sitting in a closed box, but we are not. We have a reference frame. we can look at, we know that the Earth is round, and if this was true and our surface was accelerating, means the entire Earth was just exploding at a massive rate, and also constant acceleration would mean that we probably reach light speed within a year. If you put in the standard Earth acceleration, which is 9.81 meters per second, second squared. Yeah, so this is kind of an invalid argument. And I think that's... We put in a lot of other things, but we stripped it down to this just
ask a question. So the 9.8 that we use, as I think I might have misunderstood it, but is that governed by the mass of our Earth, or it's just a universal constant?
So can you go back to Newton's formula?
Sorry,
if you can.
It was up here.
Yeah. So you see this formula, mass 1. If you put in the Earth mass there and put this just to 1 kilogram, and use the r squared, the Earth radius squared in meters, and the g from the next page, and then you get 9.81.
So that's it's a constant relative to our Earth.
Yeah. So the physical constant is this g. This is a constant, natural constant, I think.
Yeah.
It's the English term for that.
Yeah. That is awesome. Thank you so much for that.
Yeah.
Okay.
Pleasure.
So that is how you outsource the difficult questions to someone else. So thank you so much, Carsten, for your efforts in putting that together.
Not too convoluted.
Not too convoluted. Look, it's a difficult topic, isn't it? It's a hard one to tackle, and I think you did a good job of that. So thank you so much for your effort there. And if anyone else is keen to help out with some of the answering some questions, or even just contributing overall to the show, I think it is nice to bring in some other guest speakers and people to help out as well. So you're not just listening to me all day long, especially now that we can't show you all the videos that I want to. Anyway, so thank you so much for that, and I'm sure there's more discussion yet to come on the whole issue about gravity. Now, we are getting near the end of the show here, so let's just have a quick reminder of our competition. I'll just make sure I'm in the right place here. This is us today, isn't it? So just bear with me. So our competition, if you are late joining us, apart from the planet Earth, what is your favourite planet and why? And you've got about another 5 minutes or so to get your entry in. Actually less than that, because we need them in before the end of the show. So you need to get busy if you want to get your entries in. Let's have a look and see what's happening in the chat over here. Jaden, thank you. It was Dave Scott on Apollo 15 that did the hammer feather drop experiment. It was a good one, eh? So that was, there's actually a video. If you search that up, you can find a video of them doing the hammer feather experiment on the moon. Unfortunately, well, at least I've never been able to find a good quality video. It's pretty poor quality, but it does show the effect quite nicely. Clearly clever. Newton was indeed a smart dude, wasn't he? There's a lot of clever people out there, eh? Yes, Jaden, you were talking about that. So hang on, I should actually go up here a little bit, shouldn't I, to see where we were. Driver Lance, good to see you in again tonight. Thank you for coming. Actually, Jaden, you made the point that the Simpsons, they did that thing on Simpsons, didn't they, that helped spread that myth about the Coriolis effect in the toilet. So that didn't help. Okay, so yeah. Here we were thinking it was an educational show. So look, I'm missing a lot, aren't I, here? So yikes, it's going back much further than I thought it was. Look, I'm not going to get time to go through and address all of these, but I am going through after the show and reading all of the comments. So especially, well, actually in both YouTube and Facebook, I'll go through and I will try and answer all of the things and just say thanks for the ones that I've missed out tonight. So apologies that we haven't got really time to just go through each and every single one of them. Clearly Clever lives near Death Valley, so you know what Mars is like. That'd be pretty awesome, I think. Okay, so look, let's just get down here. The competition prize. Oh, thank you, John. You pointed out last week. I just can't get this one right, can I? Now, look, look, I'm going to be honest with you guys. We're having to start thinking a little bit about the money, because I keep saying that it does cost us money to run this show, and we're okay for the time being, and we're getting more Patreon supporters, so I think we're going to be all right. As long as we can keep building the channel, I think we'll be okay. But I do have to start thinking about the money. So unfortunately, I'm going to reduce the value of our prizes as just one of the ways to cut our costs a little bit, just in the meantime. Anyway, I think it's still a pretty cool prize. It's these two things here. So this is from our chemistry section over there in the shop there. So we've got a glitter slime and a hypercolor slime. So cool toys for the kids or the grown-ups that never quite grew up properly. Happy to send them anywhere in the world. So those are your prizes this week. Not quite as valuable as the ones that we've had in the past and hopefully in the future, but those are the prizes. Floydie, how are we going with the competition over there? You still working on it? Okay, so look, we're going to call time on the competition entries. Floyd's over there, very busy at the moment, just putting them all together and putting them in the astronaut helmet. Good on you, Floyd. So then we get someone from the crowd to draw them out. So while he does that, let's just have another quick look at the chat here. We've got lots of competition entries there. Andre, good to see you, Andre. Your favourite planet's Mars, because we used to live there. Nice. Remember to follow the instructions. You have to. I didn't actually make that clear this time, but you have to write comp and then the thing, but we'll let you off with that. Wendy says that was an explanation. Thanks for an excellent explanation. Thank you for that, Wendy. I always get nervous when we're tackling complicated issues. Alan's saying, sorry, the audio's not clear. Sorry about that. I might have been writing the audio levels a bit wrong there. Apologies for that. Okay, you may have to go back and have another listen and just boost the audio a bit. Okay, Janet entry was the moon. Are we going to let that one go? Because the moon's not really a planet. Yeah, I think we'll let you get away with that one, Janet. Righto. Okay, we're still going with the putting the competitions together. I sense strong feelings for Mars. Nick, you're right. It's hard to go past Mars, isn't it? I think the most common ones I normally get when I ask people what's their favourite planet, Saturn is really popular. Mars is a really popular one. If it's a school group around about primary age, it's always Uranus. It's just always. It's just, and I tell you what, followed by some jokes about Uranus. But of course, if you want to pronounce it correctly, it's Uranus. We should all know that, eh? You pronounce it Uranus, which some say is not much better than Uranus, but it is what it is. Now, Janet's asking, hey Dave, are the sites you are on free to join? So are you talking about the sites that I use here with the news stories and stuff like that? Yes, everything that I put up here, it tends to be just NASA websites. There's a few other popular space news websites, and I'm more than happy to promote them and share all my secrets where I get my sources from. Go and have a look in the show notes. The link is in the description, and you should be able to find some good sites there. So Universe Today is a really good one. The NASA website, of course. Some other good ones as well. Jenny's telling me that Jupiter is actually visible in Te Awamutu. Wow, the clouds have cleared. That's a change. Actually, it's not raining anymore, is it? Either. I can hear that. Awesome. Thank you for that. Righto. Wendy, you've got Oculus Quest 2, so you've been enjoying that. Thanks for the... we read that one out before. Okay, so I think we've got through most of them. I will try and catch up with them a little bit better when we get back to it. I'm just thinking, is there another question that we probably have got a little bit of time to tackle another question if we can. Tell you what, Gary H has asked for us to talk about Pluto the planet. Sorry, Gary, I don't know of any planets called Pluto. That's the end of that one. Am I being a bit too harsh, am I? Well, it is a dwarf planet, so we haven't got time to talk about it tonight, but yeah, we can come back and talk about Pluto, the dwarf planet. Or the trans-Neptunian object, whatever you really want to call it. Now, we had a bunch of other really good suggestions down here. Let's see. Mischief, are you in the chat tonight? I'm not sure if we've got you there tonight, Mischief, but I did say that we would try and talk perhaps a little bit about a couple of your questions. One of them was the Van Allen radiation belt. And how did the Apollo missions get through the Van Allen radiation belts? So that's a common thing that you hear in the moon hoax conspiracy theory about the radiation, the belts that surround the Earth. Look, the short answer to that is that they're just not actually as dangerous as you are being told. So they are dangerous. There are radiation belts surrounding planet Earth, and you do not want to hang around in them. And when spacecraft go through them, the equipment needs to be hardened against the radiation. So it is an issue to deal with the radiation belts. But think of it more like having an X-ray at a hospital. It's not going to kill you. And the odd burst of it is actually not really a big deal. You wouldn't want to hang around in the radiation belts. You want to get through them quickly, and you don't want to keep going through them. Just like if you're working in radiology, you need to protect yourself, but the odd exposure isn't going to hurt you. Now, Dr. Van Allen, who actually is responsible for discovering the radiation belts, himself was very harshly critical of anyone who thought that the radiation belts would be that serious. So that's the short answer. It's just not that bad. Look, to be honest, people are lying when they say you can't survive getting through the radiation belts. Perhaps I should say that they are wrong. Yeah, that's a better way of saying it. Some of them are definitely lying because some of them know better. Other people are simply misinformed. How are we looking with the competition over there, Floyd?
Okay, I'm ready.
You're ready? Okay. Who wants to do the draw tonight? Any volunteers to do the draw? Now, we've got to be careful about this, eh? We've had a couple of scandalous weeks recently. We had a draw with the prize winner turned out to be my mum, who was sitting in the audience. Then last week it was Vienna's mum who drew the prize out, and it was Vienna who'd won it. And I'm thinking, we're going to have fair go on our back soon. We're going to have the Commerce Commission falling down on us. So anyway, someone pull the name out of the hat. Karsten's going to do it. Good on you, Karsten. Thank you.
Yeah, I don't know anyone of these.
You don't know anyone?
Emma.
Emma. You're joking, really? Okay. Is that right? Wow. Okay. Blow me away. Someone else in the audience. Okay. Honestly, this is legit. Honestly, it really is all above board. Well, I'm not just doing this to save me postage, by the way. It kind of looks like I'm doing it just to, so we probably should do, shouldn't we? You only put one in. Yeah, look, we do believe. Look, well, Floyd's been busy over there doing it anyway. We trust Floyd. So, would you like to come and grab your prize? Here you go. So, well done. Congratulations on that. And maybe we should start saying that we're going to exclude the studio audience here. Anyway, it is what it is. I hope you guys trust us and believe that it is all above board. We have been sending. In fact, Tristan said tonight, didn't he, that you've got your prize. So, hopefully you guys do trust us. Look, I think that is about the end of the show. I don't think there's anything else I needed to talk about. Let's just have a quick look through the chat here just before we finish off. Good explanation. Hard topic to cover in 10 minutes. Thank you, Nick. It took me 4 years. Good on you. Look, these are hard topics. It does make me nervous when we cover these really difficult topics because it is hard to cover them and we want to keep the show a little bit light. But at the same time, you know, it's all about science and we're about learning. So sometimes we are going to take on some of the harder subjects. So thank you very much, everyone. Thank you, everyone who has commented there. Remember, if you want to get on board and help support the show and keep it going, go and see our Patreon page. The link is in the description. I think with that, it's good night from our live studio audience. Floyd, thank you over there in the background for helping out tonight. A great job as always. And thank you everyone at home for joining in. And we will see you back here again, same time next Wednesday.